Okay, everybody, so for the forecasting module number 4, in the last video we talked through a number of different quantitative and qualitative models that we can use to forecast, most of which are applicable when demand is relatively stable. So to put this in perspective, just in terms of the quantitative approaches we can take to forecasting, I just want to give a little quick overview on the different types of models we could potentially use. So the few that we talked through so far are, we could have our moving average, right, where we are basically taking a number of periods in the past that look like they would be appropriate to develop our next time periods forecast using. So this could be the past 3 years, the past 3 months, could be, you could take a bigger grab if you wanted. You could look at the past 10 years, but that would be an example of a moving average. We could also use a weighted moving average. And this would be where we apply heavier weights to more recent periods. Now we do that if we think that we want to be a little bit more sensitive to changes that might be happening in the environment, or if we're starting to see some trends, the weighted moving average would pick up on that a little bit better. Along those same lines, what we can use, instead of trying to pick just a few time periods in the past and determining which weights to use, we can use another model called exponential smoothing. And again, these 3 methods are very useful when we assume that demand is relatively stable over time. So today we're going to talk through our quantitative models that will be helpful when we assume that there's some sort of trend at play. So the demand is not relatively stable. We see that there are some changes happening, and we want to make sure that we have a model that's sensitive enough to pick up on and project our future demand based on some of those trends. So the different models, quantitative models we could use to do this are exponential smoothing with trend adjustment, and there are a couple different names for this. You might also hear double exponential smoothing. Some people also refer to it as the Holtz method. And if we assume that maybe there's a trend present, maybe it's not upward or downward, but maybe we're seeing something cyclical, maybe it's something with respect to the seasons. There are different methods we can use to understand seasonality. And to do that, we basically look at demand. If we take the simple example of months, we can take the average demand over the course of the year and figure out, looking at historical data over the past couple of years, which months tend to have higher demand. We create a seasonal index, and then when we project the next year's demand, we can use those seasonal indices to tell us what we can forecast for a particular month, let's say, if we assume that there's some seasonality at play. So we could also use something called a trend line, which we can calculate by hand, but it's much easier if you just graph the data in Excel and then choose the option to show the trend line and use that to help you figure out what that actual trend line is. And then we can basically just plug in the next year and determine what our forecast would be. So trend lines are really helpful. And all of these, again, are assuming that a trend is present. But again, all of these models here together have some commonality. They're all time series models, which basically mean that we're using historical data to predict what's going to happen in the future. There's one more quantitative model that we could consider that is not a time series, and that would be an associative model. And they're very similar to the trend line in terms of how we graph and understand the data. But what's different here is that instead of looking at historical data over time and seeing if a trend is present, we're going to use other factors in the environment that might be an indicator of whether or not our demand is going to increase or decrease. So this could be, again, economic factors. There could be other things at play in the environment that are, again, going to tell us whether or not we can expect demand to increase or decrease. So we would do this using either a simple linear regression or we would potentially have a multiple linear regression. And we would use a simple linear regression if there's really only one other variable that is helping us to figure out or predict what our forecast would be. But if there are a number of factors that are influencing our forecast, we would potentially want to look at a multiple linear regression model. We won't cover that in this course, and it's not something, it's very complicated to actually determine the multiple linear regression model just by doing the calculations by hand. So typically we use some sort of software package. Something like Minitab, even Excel can do it. So that is generally the approach that you would take. But for purposes of this class, I just want you to understand the difference between the simple linear regression model and the multiple linear regression model and when you might use either one of those. Okay, so again, all of these are time series models. These are for particularly useful when you have stable demand and you just want to smooth it out over time. These are useful when you know that a trend is present, and if there are other factors that are influencing your forecast, you would want to pick up an associative model. Again, there are some packages, and especially the Amazon SageMaker services that are out there now. There's a lot of models that will incorporate kind of all of these methods. Those are certainly more sophisticated, but especially if you're at a smaller organization, it's good to try to be able to play with some of these different models and determine what's going to give you the lowest forecast error. So with that, what I want to do today is I want to walk through this exponential smoothing with trend adjustment, or the double exponential smoothing method. So there is an example in the text, so I'm going to follow along with this pretty closely so that if you've got the book, you can follow through with how you might do this as well. So this is an example where we've got our actual demand over a series of months, so over 9 months. In this case, we think that a trend is present if we just look at the data. It looks as though there might be an upward trend at play here, but we're not totally sure. So we want to try exponential smoothing with trend adjustment to actually see if that's going to give us a more accurate model. So for now, we're just going to pick, again, when you initially pick your alpha values, it's pretty subjective. Again, a lower alpha value is going to assume that demand is a little bit more stable, and you want to actually smooth demand over a number of time periods, whereas if your alpha value is higher, if it's closer to 1, that's going to place more weight on the most recent time period. Beta value is actually going to smooth our trend. So where we just had alpha when we had regular exponential smoothing, now we have a beta value, which is our smoothing constant for the trend as well. And the same rules apply. A lower beta value is going to smooth the trend more evenly. It's going to more evenly distribute it over all of your time periods. If it's closer to 1, it's again going to, it's basically going to say that the trend that we saw over between, let's say, months 1 and 2 is what we want to predict the trend will be for time period 2 to 3. So let's walk through what this will look like. So the formula for double exponential smoothing is going to be, and this is also referred to as FIT, forecast including trend, and we're going to do that for time period T, is essentially going to be an exponentially smooth forecast plus an exponentially smooth trend. Now, our equation here for our exponentially smooth forecast is a little bit different in the double exponential smoothing model. It's going to be our alpha value, all multiplied by the actual demand in the last time period, plus 1 minus alpha, all multiplied by the forecast from the last period, plus the trend from the last period. So the way this would work, if we are looking at, let's say, month 2 in our example, so our forecast for month 2 will be, and in this case again, our alpha value is going to be 0.2 and our beta value is going to be 0.4. So we've got 0.2 here, all multiplied by the actual demand from our last time period, which is in this case from month 1, 12, all plus 1 minus our alpha value again, and that's going to be multiplied by our forecast from the last time period plus our trend from the last time period, and those values are 11 and 2. Okay, so if we go through and solve for this, this is going to be 2.4 plus 0.8 multiplied by 13 and this is going to give us 12.8. Okay, so this would be the value that we would put in here for month 2. Our smooth forecast is going to be 12.8. Okay, but we're not done yet because we have to figure out what the smoothing formula is for the trend, because we believe that a trend is at play here. So to get this exponentially smooth trend, we want to use the formula. Our trend for time period t is going to be our beta all multiplied by this time period's forecast minus the forecast from the last time period plus 1 minus beta all multiplied by the trend from the last time period. Okay, so if we're going to do this for month 2 in our example, our beta value again is 0.4. We're going to multiply that times the forecast from this time period, which again we solved here and is 12.8, minus the forecast from the last time period, which in our case is 11. That's going to be plus our 1 minus 0.4, and that's all going to be multiplied by the trend from the last time period, which is 2 here. So if we go through and calculate, our trend for time period 2 is going to be 0.72 plus 1.2, and that's going to equal 1.92. So we can include in here, this will be 1.92. Okay, and then when we determine the forecast including trend, we just add these two values, and in this case that's going to give us 14.72 for this time period. Okay, so again here if we calculate the forecast including trend for time period 2 is going to be this, our 12.8, our forecast, our exponentially smooth forecast, plus our exponentially smooth trend, 1.92, which is going to be 14.72. So for purposes of understanding why you would use this method, again, we're using this when we believe that a trend is at play. Let's compare it to if we just did the regular exponential smoothing model. So if you remember, the exponentially smooth forecast for just our regular model is going to be, let's see, our forecast for time period t is our forecast from the last time period plus our alpha value, all multiplied by the actual demand in the last time period minus the forecast in the last time period. So our forecast here, if we were going to compare, if we just did regular exponential smoothing for month 2, would be here our forecast from the last time period again is 11, plus our alpha in this case is 0.2, all multiplied by the actual demand in the last time period, which is 12, minus that forecast again, which is 11, and that is going to give us a forecast in time period 2 of 11.2. So you can see the difference here because our forecast including trend is giving us a forecast of 14.72, where regular exponential smoothing is just trying to smooth out the forecast using the actual and the forecasted demand from the previous period. But again, exponential smoothing models are actually depending on your alpha, including all of the previous time periods. In this case, it's giving more weight to a number of time periods as opposed to just focusing more heavily on the last time period. So here we can see that our forecast for month 2 of just using regular exponential smoothing is only going to be 11.2, which is going to be pretty far off from what actually ends up happening. So if you went through and did this model, and this is similar to the homework, because in this case if we eventually wanted to get a forecast for month 10, what we have to do if we want to test out how accurate a model is we have to start from the very beginning, and we have to use the actual demand and the forecast and the smooth trend from that first time period, and we have to work our way down. Again, because we can't just start here, because we actually have to use our model to calculate the forecasted and the smooth trends for each time period, because they build upon each other. And then if you wanted to determine, how accurate it was, if you were looking at multiple models, you could use any of the 3 forecasting error methods that we talked about in the previous video to determine which one is actually going to give you the most accurate forecast. So again, you're going to see regular exponential smoothing on the homework and on the exam, and you're also going to see that forecast including trend. I want you to be able to not only calculate these, but understand the differences in which scenarios would be more advantageous to use these different methods.